Let's continue our discussion of programming in Unity by discussing the concepts of object-oriented thinking and how it translates into the Unity environment. Unity follows an object-oriented approach in the way it is structured and in the way that you write code. I like the object-oriented approach as I think it parallels the way we think about the real world around us. Everything is considered an object. For example, a clock is an object in the real world. It has properties such as its color, weight, size, and probably most importantly for a clock, what time is it? And it has methods or actions that you can do with it, such as the ability to set the time, the ability to set an alarm, the ability to snooze the alarm, and so on. This same concept could be translated into code. That is, in code, you could have a clock object that has a property or variable that we can reference to determine the current time. The clock object could also have methods or functions to set the time, for example. When building games in the Unity editor, virtually everything you're working with can be considered an object. The editor makes these objects visual. For example, the scene and the hierarchy view visually represents game objects. You can also consider the components that are attached to game objects as a type of object as well, with their own properties and methods, some of which are made visual through the Unity inspector. So, for example, this game object has a transform component. The transform component is an object that has position, rotation, and scale properties, as well as methods that you can use to translate or rotate the object. I believe that if you understand what is going on in the Unity editor, you are halfway to understanding code. One important concept in object-oriented programming is that of classes. Classes are templates for creating objects. For example, we could have an enemy class that defines how an enemy object works. We then instantiate or create objects from that class. The properties and methods of the object are defined within the class, but each enemy could override some of the defaults for the class. So, for example, the class could define the enemy as purple, while the objects derived from the class are set to green and orange. Prefabs are one way to visualize this concept in the Unity editor. That is, a prefab is a template game object. We can create many game objects from the prefab. While each game object has its own unique attributes, they are all based off of the original prefab template. To sum up object-oriented concepts, classes are templates for objects. Classes are linked in a hierarchy. So, for example, in Unity, there is an object class which is the parent of the game object class. You can create your own custom enemy class, which is a child of the game object class. A class can do anything its parent class can, and its parent's parent, all the way back through the class hierarchy. This is called inheritance. A class can override its parent's functionality to do something custom. This is called polymorphism. Objects are instantiated from a class. So if you want to create several enemies, you can do so by instantiating the enemies using the enemy class. And an object gets all the properties or variables and methods or functions that are defined in the class. This slide summarizes a lot of the object-oriented concepts and terminology that we'll use when talking about C# in Unity.